Good day to you at wherever you are watching my video. I also thank you that you always make a time out of your schedules to watch my videos on YouTube. Please, I beg of you to subscribe to my YouTube channel so as to get videos on other mathematical topics and also to learn at your own pace. Today we are going to consider plane geometry 2, and that is circle theorems in the Form 2 syllabus. And we would like to look at angles in the same segment. You already know segment, but for the sake of this video, I would like to talk about it. Line CD is the chord, and that chord divides the circle into two segments. We have the small area, which is the minor segment, and the bigger area above the chord, which is the major segment. Now look at this beautiful diagram you see on your screen. You can draw same on a sheet of paper and label it as you see on my screen. You can also paint the angles. Now, we are going to find out if we place one of the angles on the rest and they would be equal or not. So let's see what happens. I am using GeoGebra. So look at how angle CED is placed on the rest of the angles. Okay, what do you see? You can see that angle CED is the same as angle CFD. Now let me move angle CED again and place it on CGD and see what would happen. It is also equal, which means that all these three angles are equal. It tells us that when angles are subtended by a chord at the circumference of the circle, those angles are equal. Let's see the property, what the property says. Angles subtended by the same arc or chord at the circumference are equal. So whenever you see angles at the circumference of a circle, find out if they are all on the same chord or they are all on the same arc. If they are all on the same arc or chord, it means they are equal. At times the chord wouldn't be drawn, but since the arc is part of the whole circle, you may see that arc. If the chord is drawn for you, then you are lucky. And if it is not drawn, you can also draw your own chord. Now, I am going to move some of the angles for you to see. Now, let me place one of the lines of these angles on the center. So you see that one of the lines of angle CED is passing through the center. I can even do same to this. Good. Same thing to angle CGD. And let's see if still the angles would be the same. Look at it well. You see they are the same. Let's move it to the last one and see if they are also the same. Good. So it doesn't matter where any of the lines would pass. The only thing to look for is that all the angles should be in one segment and they should be subtended by a chord. Now, let me place it again. Let me shift it. This to other part. You see it where it is. Let me shift this to another side and let's see. Now let me move the angle and see. Good. It is equal. Now let me move it. It is equal. So no matter where any of the angles would be, one thing you should know is they should be at the circumference of the circle and also in one segment. Let's see this. One may think that when the angle is at the minor segment, the answer would be different. So let's see that one too. I am moving the chord. I am moving the chord. Okay. So now you see that the minor segment is up there and down the chord is the major segment. Let me move the angles again and you see. Good. You see they are equal. I hope you are following well. Now let's see. Good. It fits equally. This tells us that when the angles are in the same segment subtended by the same chord and they are all in the same segment, then the angles at the circumference are equal. So we can say that angle CED is equal to angle CFD and is equal to angle CGD. So all the three angles are equal. They can be two angles, they can be three, they can be four, no matter the number of angles that are formed at the circumference. They may be equal provided they are subtended on the same chord. Now let's move and solve examples so that you may get better understanding of the topic. Question number 1. Find the values of angles x and y of the circle with center of A below. This is very simple. If only you have the property on mind. And I usually tell my students that when you get questions on circle theorem and it seems like you are panicking, it puts fear in you, just start turning your paper. Whilst you begin to turn the paper, and if you really know the properties, they would be coming in mind, and you may know which property to apply to solve that question. For this question, we can see the circle and this diagram in it. Looking at the diagram, we have two angles touching the circumference up the circle and other two touching the circumference down the circle. Let's see how we can solve this. You can also try it before you look at the way how it is going to be solved. Now let's look at the solution. When such diagrams are given to you in class exercises or in your final exam, just find out where the chord is, or if there is no chord, where you can find an arc on which you could stand to solve the question. So for this diagram, we could see that there is an arc here, the CD. So if you want to draw the chord, as I have already said, you can also draw your chord. The arc is already drawn, so there is no need to draw another arc. So we are using either the arc or the chord I have drawn here, the one in red. We can see that all the angles at the top here touching the circumference are on the same chord, and hence from the rule we could say that these two are equal. Therefore, y degrees is equal to 20 degrees. This is done by observation. So you write that angle CED, and look at CED, that is y. That's why I have put y degrees in this bracket, is equal to angle CFD. And what is the angle CFD? It is 20 degrees. So since we know that angle, it is the same as the y degrees, and therefore we can write that y degrees is equal to 20 degrees. So this is done by observation. You could pause the video and solve for the value of x degrees. Now, as I have already told you, if you see that this diagram is worrying you, you can turn your paper till this side faces down and this side moves up. If you are done with your answer, then let's solve it together. Good. That is the chord on which these two angles are subtended. And if you want to draw the chord, this is the chord on which these two angles subtend. So now using the arc, if these two angles, angle ECF and EDF, subtend on the same arc, that's arc EF, then we can say they are also the same. Therefore, you write that angle EDF, which is S degrees, is equal to angle ECF, and that is 33 degrees. Therefore, we can conclude that S degrees is equal to 33 degrees. You see how simple it is? If you still find it difficult to understand, go back and watch it again. Let's see question number 2. Find the value of angle CED of the circle with center A below. Look at it. We can see that all the 3 angles subtend by the chord CD, and they are all at the circumference of the circle. Therefore, this is the first thing telling you that all the angles are equal. If all the angles are equal, then please solve it for me as you pause the video. I hope you are done. Let's solve it together. We can see that from the diagram, because they all subtend on the same chord, we can say that the question says find CED, angle CED. This is angle CED, so you want to find this angle. Therefore, angle CED is equal to any 2 of these angles, any 2 of these. But whilst I was solving, I equated it to angle CGD, which is this angle CGD. I didn't use the one in the middle, CFD, so you can use that too. If they are equal, then what is angle CED? The angle CED is 2x minus 20 equal to angle CGD, and angle CGD and angle CGD is S plus 10. Now, once you have done this, group like terms. Some may say, let the S cross the equal sign. Because it is positive, it becomes negative here. Let the negative 20 cross the equal sign. Because it is negative here, it becomes positive here. Good, but the right way to do it is this. We want to move this S to where 2x is, and the S is positive, so we must subtract x from both sides of the equation. That's why you see minus x here, and after the equal to, you see minus x here. Now, the negative 20 is to be moved to where 10 is. Because it is negative, we add positive 20 to both sides. That's why you see plus 20 here, and then plus 20 here. It is an equation, therefore what is done to the left hand side should be done to the right hand side, else it may be wrong. Now it may be left with 2x minus x. Negative 20 plus 20 would be 0. This side 2x minus s would be 0, so it would be left with 10 plus 10, and that is what you see next. 2x minus x would give us x, and 10 plus 20 would give us 30, meaning s is equal to 30. But the question says find angle CED. So if you get 30 and you stop here, you are not done. You may lose the marks for the final answer. Therefore, you have to substitute 30 into 2x minus 20. Angle CED is equal to 2x minus 20 all degrees. So wherever you find x, put in 30, and you know that 2x means 2 times x, and therefore it will be 2 times 30. That's why you see this 2 times 30 minus 20. And then we get 2 times 30 is 60 minus 20. When you simplify, you get 40 degrees. Therefore, we can say that angle CED is equal to 40 degrees. See how simple this one is. At your own time, leisure time, just equate any two of these angles and solve for x, and you would see that you will get 30 degrees. Then you substitute it into 2x minus 20, and you see that you will get 40 degrees. Now, our assignment. Calculate the angles T and H of the circle below. That's your question. Pause the video and solve it, and you compare your answer with that of mine. T is equal to 52 degrees. Solve for H before you look at my answer. H is equal to 40 degrees. Well done if you had at least one of these answers correct. Please, I beg of you to subscribe to my YouTube channel for more videos. If you are a teacher or a student, you can subscribe, you share, and you comment. Now, I say goodbye to you at this point. May God be with you till we meet again on this same platform. Bye.